so sigma cross, so that's a particular topology.
Yeah.
You're saying that no geometry makes this topology a solution.
Right. It's not hyperbolic geometry. So you may think like this looks, and you're making the geometry more complicated. But actually, because like this mechanism is within this kind of hyperbolic geometry, this adding an insertion makes this calculation possible. So this object was studied last year by Zhang and myself. But today I'm going to talk about how to do that using their work, so the Virasoro-T. So Virasoro-T is something that we start from the SL2R² Chern-Simon theory on sigma times R, and then we quantize the hyperbolic matrix on sigma. So it has Hilbert space H of sigma is the space of the conformal blocks on sigma. So the Hilbert space of gravity is two copies of the H sigma canceled together. So this theory works only on shell, but we are trying to do on-shell calculation and try to extrapolate to off-shell geometries. So in Virasoro-T, Monason and Miles wormholes are special because they represent the identity on the Hilbert space H sigma. So the Z Liouville of a Monason and Miles wormhole sigma times I is the sum of this conformal blocks. So basically this is resolution of identity. But we also need to formalize it by the inner product of the conformal blocks. So, and then we calculate the gravitational partition function by doing two copies of Z Liouville and then sum over the relative mapping class group between the two boundaries. And then, so just they do this calculation and we get the result. And the limit that we take the mass going to 0, we get the answer of this torus wormhole with one insertion on each boundary. This is proportional to 1 over delta squared times this integral over 4 characters. So this character is given by this formula below. However, this doesn't completely agree with Collar-Jensen's answer. So in their answer, they have a sum over this mapping class group, and the summand is that it's an integral over 4 characters, but also multiplied by this pp bar. So we are missing this factor of pp bar. So what is wrong with that? So like to understand what is wrong, we try to do a simpler calculation by going down 1 dimension to JT gravity. So we can do dimensional reduction for the BTZ black hole to go to a disk in JT gravity. And analogously, a torus wormhole would reduce to a cylinder in JT. Now, we think about the partition function of a cylinder versus this object with a cylinder but with 1 insertion on each boundary on the left side. So we first talk about this calculation on the right side, how to calculate the partition function of a cylinder. So we start with a cylinder and then we cut it in the middle to make 2 trumpets and then we glue them together. But when we glue them together, we need to take into account of the relative twist between these 2 trumpets. So this gives additional factor of B. So then, like evaluating this, we get this answer on the right-hand side. However, if we evaluate this cylinder with 1 insertion on each boundary, we get a different answer, which is this. So now, let's see how we can recover the left-hand side answer by doing the right-hand side thing. So we do this by taking into account of windings. So like when you include the geodesic, you don't just have it like straight. You also need to include the case where this geodesic would wind around the cylinder by n times. So this is accounted for by this factor e to the minus delta times b times n, and you sum over from negative infinity to infinity. So this gives a factor of 2 over b times delta. And then you do this calculation same as what we do to calculate the partition function of the cylinder. But then we include this additional factor taking into account of the windings. plus defects. But people would also want a 3D calculation. So we have a proposal of doing a 3D calculation using Biot-Savart TQFT. However, there is something wrong with this Biot-Savart TQFT calculation, which I will demonstrate. Okay, so what is the setup? So in ADS3, we impose a boundary condition which is a flat torus. So the imaginary time circle TE, this is contractible circle, is of length theta, and then the spatial circle is parameter phi is of length theta. And then we get the BTZ black hole by filling in this torus, so it becomes a solid torus. So now let's construct the SL2Z black hole. So how do we do that? So we're given this torus boundary, and then we do an SL2Z transform on this torus boundary. So gamma is an element of SL2Z. This is this matrix A, B, R, D. And then we add gamma on tau to get A tau plus B over R tau plus D. And then after doing this transform on the torus boundary, we fill in the inside. And then we get an SL2Z black hole. So this red circle is the spatial circle. So SL2Z black hole partition function only depends on the ratio between R and D. So we will label these black holes by these parentheses R, D. So in the near extremal limit, which is the limit shown here, we can calculate the density of state of the BTZ black hole. This is proportional to e to the s naught times p squared. And we could also calculate the density of state of a SL2Z black hole. It turns out the leading contribution comes from this particular SL2Z black hole labeled by R, D equal to 2, 1. And this density of state is proportional to minus 1 to the j power times e to the s naught over 2. So if you stare at these two things, you'll find that, like in the near extremal limit, you take p to be very small. Then if the spin is odd, then the second term will be negative, and it will dominate over rho BTZ. So the whole thing will be negative. So this is the negativity problem with the density of state. So we could map this density of state to some two-dimensional density of state. So a BTZ black hole is mapped to a disk. And an SL2Z black hole labeled by RD, R, D is mapped to a disk with one defect, alpha. Alpha is 1 over R. So let's recall that the partition function of the in JT of this disk and trumpet are given by the following things. And then we have the rho naught is the density of state of this, rho 1 is This combinatorial factor is basically telling us about the mapping class group. And then we take into account the dimensional reduction represented by lambda, and we sum over different number of defects. And in the end, we get an answer that's rho is proportional to rho btz times the square root 1 plus 2 lambda over p squared. So this solves the negativity problem by non-perturbative shift of this p.
here you compute partition functions. Can you correlate, say 2-point functions in your sort of GPU?
Yes, like the,
If you get the right answer,
what object? Oh, if you calculate an on-shell object and match with those, it's kind of a correct answer. It's more like you don't know how to calculate this off-shell object. Like how to take the limit at mass goes to 0. Yes, Luca.
You go first. I just said answer what you described for the two boundary curves normal. Is
Yes.
that you think there is a calculation in the reciprocity geometry that actually computes the spectral functions to have positive support, or do you think that's not possible within the area of the I mean, you explained very clearly what the issue was what happened last week.
Yes.
Can it teach and but will one actually get an answer there?
Like for the torus protocol.
Yeah.
It's not entirely clear how it affects that, but then it's possible to fix that, I would say. Yeah. Yes.
I have maybe a related question. Do we know how to fix it in JP graphically? Can we reproduce any off-shell geometry by taking the limit of a of an on-shell geometry, with a very light insertion?
So what I just showed is how to do that for a cylinder, but you don't know it for like unwhole sphere. So that's why it's more difficult for more boundaries.
And the second question is, should I view the calculation that you did as not necessarily computing the real partition function, but rather computing the correlation function of some very light effect operators?
Yes, I think so.
Okay.
But for cipher manifold, it's not entirely clear what. But yeah. Yes.
This Cynthia Yan binomial half-n thing, do you have a combinatoric concept? Is it an integer multiple? Is